And so this is our first Neetcode session. And it's gonna be held every Friday from 2 to 3 p.m. And we started a bit late, unfortunately, because I was waiting for more people. But these sessions are gonna be very helpful, like in the next upcoming semester, to get you guys prepped with technical interview questions and enhance your proficiency in data structures and algorithms. So we're just gonna get started real quick. So what I want to talk about first is briefly is using UMPIRE. So this is the framework I use for when I tackle these lead code problems, and it's basically has six steps. So understand is basically knowing what the problem is, and number two is match or like the method. So like, is it a linked list or using a DFS? Is it a graph question? And the third one is planning. So like add pseudocode, add steps and that stuff. And four is where we start to implement the code. So in this session, we're going to use Python, and afterwards, number five is basically reviewing it. So like running through the code that you just typed and going line by line and evaluating the problem. So like, what is the time and space complexity? And afterwards, you could be asked like a follow-up question on like, can you optimize this in a way? So we're going to start with something easy, which is two sum. Can anyone see my screen? Okay,
I can see your screen.
okay, okay, good. So, so we're gonna start uh, with two sum here. So there's two ways to do this. I'm gonna start with what everyone would do first, like as a beginner. So we're gonna start with the understand part. So what it's asking is, given an array of integers, and you have a target integer, return the indices I and j where nums I and nums j equal the target, and I is not equal to j, right? So for the understand problem, find two indices where its values add up to the target value. And we know that the two indices cannot be the same, so the two indices can't be duplicated, right? Does that make sense? So it has exactly one pair. So we're gonna have two indices that we're gonna return. So not one, not three, but two. So so how would we try to tackle this problem? So this is where like like the method comes in, right? So what I would do as a noob is use a nested for loop, right? So we briefly know the method, so we can do a nested for loop, and what that does is for each iteration in I, we go through j iterations. So this is what it's going to look like. So we start at 3, and then there's a internal loop which goes through the rest of the numbers. So 3 and then 4, 5, 6 for nums j. And then there's also going to be a if statement. So we're going to compare nums I and nums j, each number at nums j. So we're going to see if it adds up to the target. So 3 plus 4 is going to be 7. So we're going to return I and j. So we're just going to keep searching which pair adds up to the target. So pretty much a nested for loop. And like I said, for the procedure, I think that's what I mentioned. So, right, so compare, so outer loop is going to be I, so inner loop is J. Yeah, so for each I, we go through each uh, we go through the rest of the integers in J. So this is gonna be so this is what's gonna look like. Alright, so we have so we are given nums, which is the list, and the target. So we're gonna say for I in range, we want to specify like the length. So length of nums. So for I in range n, and for j in range I plus 1 n, we're going to say if nums I equal plus nums j equals the target, return I and j. Right, so that's what it's asking. So we want to return I and j. So something else you want to consider is like an edge case. So what if we don't have two elements that add up to the target? So it's important that we find an edge case as well. So it's important to read through the problem, and I believe that we're guaranteed to have two elements that add up to the target, so we don't need to consider that edge case. So does this make sense? So for each I, we iterate through j, right? So like I showed here, right? We can't iterate through the same element twice. So like we can't have 3 and then 3 for nums I and num j, for example. And yeah, so we're just gonna run this real quick, and we're gonna see that we passed the test cases, and we're gonna submit it, and it works, right? So this is the brute force way, and I'm gonna tell you that the time is going to be O of n squared. None, and I will explain why. And as for the space, it's going to be O of 1, constant space. So the reason for space, why it's constant space, is because we didn't create a new array. We didn't make any space, basically. So we just used the array itself to iterate. And as for n squared, the time, it's because we did like a nested for loop. And not only that, for each num in I, we iterate through each num in j. So looking here, for I, we iterate n times, and also for j, we iterate n minus I times. So when you multiply these two together, it's pretty much n squared. So that's why the time is n squared. Okay. So that was the brute force ways, and now I'm going to show you a more optimal way. And going back to our board, so this is our second method here, and this is pretty much a hash map. So if you heard of a hash map, it stores it stores a key and a value pair. So key and a value. That's pretty much what hash maps store. It's a key and a value. So here I already drawn it out. So it's going to be 3 and 0. And this means that the 3 represents the element, right? So the element itself, and the value would be the index, right? So 3 at index 0, 4 at index 1, and so on and so forth. And we're going to iterate through nums, but we're going to iterate through it once. So what we're going to do is, for each iteration, we're going to take the target, which was 7, for example. We're using this example here, and we're going to subtract it with nums I, right? So it's going to be 7 minus 3 is going to be 4. So D is the difference, right? So if 4 is in the map here, we can return this index as well as the current index at I. So this is going to be a quicker method. So I'm gonna create a I'm just gonna call it map. Yeah, we'll just call it map, right? So and this is going to be special. So for I num in enumerate nums. Right, so what enumerate does, it extracts like the index value and then like the value itself, like I mentioned. So 3, for example. And we can use that to our advantage, right? But we want to calculate the difference first. So difference equals target minus num, I believe, yeah. And we're gonna make an if statement here. So if diff in map, we can return the index. So map diff, that's basically the value of the index and I itself. But we also want to add this to the map. So map num equals I. Right. So we're gonna walk through the code here. So what enumerate does, it extracts the value and the index, and for diff here, we're gonna find the difference, and this difference gives us like the other value we need, which is guaranteed to be in nums, but we're searching it through the map because it has index value. If that makes sense, right? So we're gonna check if the difference is in the map, we can return the index, which is basically map div, and the current index, because that's what we added. I mean, that's what we needed as well. So like at the current index, right, if we find a difference, and if it's in the map, we know that the index of the difference and I, they both add up to the target, right? And of course, this just adds the element and the index to the hash map. I believe this is the solution, so let's see if this works. Yeah, so this is what we have, and we're going to submit it, and it clearly works, alright? So I want to discuss the time and space complexity of this one. So this one was the brute force solution, and this one is the more optimal solution. So the time would be O of n, because we iterated through nums and times, right? So we just passed it once. We looped through it once. And as for the space, it would be O of it because we allocated memory for n elements, right? So this is what this line of code would be, right? We allocate, yeah, so for each element, we're going to add it to the map, which will consume O of n space. That makes sense. So there's a lot of trade-offs here, right? So the advantage of using brute force is that we have constant space, but the time is, you know, it takes a long time. It's slow. As for the optimal solution, the time is more efficient, but the space, it isn't constant space. So these are, so I demonstrated two solutions, and afterwards, what you have to consider is like the trade-off. So pretty much what I mentioned here. So this is good. The brute force solution is good in space, and the optimal solution is good in time. So you have to make trade-offs like that, and you have to evaluate it. So, so that's pretty much two-sum. That's pretty much actually that's I can actually find another problem, and we're gonna try this one here. This is more advanced, obviously. I think it's a medium problem. So you don't have to speak out loud, but I want you to um, send a message in the chat, like what this problem is asking us to do. And like how can we solve this problem, basically. Okay, so I understand this is a very difficult problem, but it's pretty much the challenge. Challenge yourself. So I know this is a lot. I'm sorry, but does anyone have questions so far?
I don't have any questions. I just want to say this is all new to me. I don't know how to code at all, but I just wanted to come to see what it was because I will have a coding class coming up in my degree program. So I'm actually just here to like listen and observe to see what I can learn from this.
Oh, great, great, yeah. So at least you know two-sum, and you know the brute force and the optimized solution. And we're gonna talk about this one as well. All right. So it's similar to two-sum. So it's similar to two-sum, right? But the array is sorted, right? So return to indices, one indexed. So it's one index as well. That's important, right? One indexed. And this part is important because usually we start with 0 and not 1, right? So this is big, again, very important. And like in twosome, we started with a 0 index, but here's a 1 index. So this is something we need to note. And yeah, so return indices that are 1 indexed and such that they add up to a given target, just like in twosome. and index 1 is less than index 2, right? Because the array is sorted. And index 1 and index 2 cannot be equal, so you can't use the same element twice, just like in twosome. And the solution must use O1 space. And I can tell you right now, we're going to use what is called two pointers. And just disregard this solution. Two pointers in a nutshell is, let me find my drawing thingy. Sorry about that. Two pointers in a nutshell is just basically having a left pointer and a right pointer, right? And you would specify these as indexes, right? So, what am I doing? Okay, so left is equal to 0, and right is going to be the length of the array minus 1. So like that. And basically with two pointers, you want to move these around. Right, so you want to move left as much as you need or right as much as you need. Okay, so we're going to use this example here with two pointers. The array is already sorted anyways, right? And let's say our target is going to be 10. Right? So how this works is that we're going to add the elements together. So the array at L plus the array at the right pointer. And of course, if it equals the target, we return ln r. We return L R. I know I'm repeating myself, but so if we add these two together, and if it meets the target, we return left and right, and we have to keep in mind that the index is 1, so we're just going to add 1 to both of these, and we have another edge case that, not edge case, but we have a different case here. So what happens if it's less than the target, right? So we can add 3 plus 6 because L and R are at 0 and 3. So 3 plus 6, that is going to equal 9, and it's less than 10. So what should we do? We should move the left pointer because it increases the value, right? And afterwards we can check again. So L plus R, array of L, plus array of R, that equals 10. So we're going to return, I believe it's 2 and 4. Yeah, 2 and 4. So does that make sense? So we're going to initialize our two pointers. So the left pointer equals 0, and the right pointer equals the length of numbers minus 1. And we want to make a condition here. It's a while loop. So while L is less than R, right? So as long as L and R are, so as long as L is less than R, we don't have to worry if the loop has to terminate. Because never R, the right pointer, is going to be behind L and vice versa. You could also make a statement of that L and R equal, that could be applicable too. But we have to deal with two indices. That's why I don't think we don't need to put the equal sign here like this. So let's say if numbers L plus numbers R equals the target, we can obviously return L and R. Keep in mind this is one index, so we're going to add 1 to both of these. Right. And as for our edge cases here, keep saying edge cases. As for other cases here, right? So if we find out that the array of L plus array of R is less than the target, we're going to move our left pointer. So left plus 1. And if it's greater than the target, we're going to subtract the right pointer, like this. So I'm just going to implement these. So it's going to be, we said L plus 1 and R minus 1. Right? And of course we need to look for actual edge cases. So it's guaranteed that there's going to be 2 elements that add to the target. So we're gonna run this and okay. So what happened here? Okay, maybe we do need to add the equal sign. Okay, hold on. Okay, I did that. Okay. Oh, I see what happened. Okay. It's supposed to be a greater sign. You know, when you do these coding interviews, you find stupid mistakes. So this is where the review concept comes in. So we run this, and of course we accept it. Right. So as for the time and space, this is going to be O(n), and the space is going to be O(1). And the reason why the space is O(1) is because we didn't create like a new array to allocate n numbers from the numbers array. So that's why it's constant space. We just use the array itself to search. And the time is going to be O(n) because we iterated through the elements. We iterated through n elements in numbers. So that's why it's going to be O(n)'s time. Yeah, and the space is constant, right? So this is how two integer sum works using 2 pointers, and it's a pretty easy medium problem once you get the hang of it. I can guarantee you that 2 pointers is an easy concept to learn once you get the hang of it. So do you understand how 2 pointers work is you initialize the left pointer as 0 and R as the length of the array -1, and you move these around. And the purpose of these is to like compare different elements based on their indexes.